Alright, so today we're going to go over section 2.5, which is limits of summation and the area problem. Okay, and so we have some different formulas for limits of sums that we need to know. So we'll start with our sum formulas, and then we'll look at limits in a second. Alright, and so for the first one, it says the sum from any 1 to n value of any constant is that constant times your n value. For number 2, the sum from 1 to any n value of I is equal to n times n plus 1 divided by 2. For number 3, the sum from any 1 value to n of I squared is equal to n times n plus 1 times 2n plus 1 divided by 6. For number 4, the sum from 1 to any n value of I cubed is equal to n squared times n plus 1 divided by 4. And then for number 5 and 6, that tells you that you can break up sums into the parts of their pieces, and you can pull constants out in front of the sum. So for number 5, the sum from any 1 value to n of a plus b is equal to the sum of a and the sum plus the sum of b. And for number 6, the sum of some constant times a is equal to the constant times the sum of a. So you can pull the constant out front. Okay, so if I look at example 1, I'm given the sum from 1 to 200 of I. And I know that my sum formula for I is n times n plus 1 divided by 2. And I know that my n value is 200, because that's your n is the number you end your sum at. So if I plug in 200 in for both of my n's, I get 200 times 200 plus 1 divided by 2. So I get 200 times 201 divided by 2. And you guys are going to have to tell me what that is. $4,200 or 40,200. So your sum would add up to 40,200. So if you had to actually add those, that would be a lot of work. Did you divide it by 2? No, you did not. It's not 40,200. Divided by 2. Divided by 2. What is it divided by 2 then? 20,100? Okay. Okay, so if I do the same thing for the sum from 1 to 50 of I squared, I know that I squared is n times n plus 1 times 2n plus 1 divided by 6. And in this case, my n is 50. So if I plug in 50 for all my n's, I get 50 times 50 plus 1 times 2 times 50 plus 1, all divided by 6. So 50 plus 1 is 51. 2 times 50 is 100, so plus 1 is 101 divided by 6. So what do we get for that? $985? $925, okay. So 42,925. Do you want to keep looking at plugging into formulas, or want to move forward and look at this one? It's kind of complicated, I guess. Alright, so the limit as n approaches infinity of the sum of from 1 to n of 1 plus I over n squared times 1 over n. Okay, well 1 plus I over n is the same thing as n plus I over n. And so if I square that, then I'm going to square the top and bottom. So n squared plus 2ni plus I squared divided by n squared is my product if I square the top and the bottom. And then I'm still taking that times 1 over n. So if I do that, then you multiply fractions straight across. So the top stays the same, so n squared plus 2ni plus I squared. And n squared times n gives you n cubed. And I'm still trying to find the limit of that. Okay, and as we looked at yesterday, it's easiest to find limits as they approach infinity if you do them as fractions. So I'm going to divide everything by n cubed to turn it into a fraction. So n squared divided by n cubed is just 1 over n plus 2ni. Well, this n will cancel with that and become 2I over n squared. And I squared stays I squared over n cubed. And n cubed divided by n cubed is just 1, and so I don't really have a fraction anymore. And so then I know that as n approaches infinity on any of these functions, what is that going to equal? Let's start with 1 over n, 0. 2i over n squared is 0. I squared over n cubed is 0. So my limit of that sum is 0. Okay. And so we use limits to actually find areas underneath curves. In calculus, they'll call it integration. Here we just call it the area of a plane region. So to find the area of a plane region, you take your limit as n approaches infinity of your sum of your function of a plus b minus ai over n times b minus a over n. And so the function part gives you your height, the b minus a over n gives you your width, and when you multiply, then you get an area. And the a and b come from your interval. Okay, so if I look at example 5a, I'm given f of x equals x squared, and I'm given an interval of 0 to 1. And I'm asked to find that area. First thing I'm going to do is find my height, which tells me to find f of a plus b minus a I over n. Okay, and I know that a and b come from my interval. So if I direct sub in a and b, then I get 0 plus 1 minus 0 I over n. So the 0 cancels, 1 minus 0 is 1 I over n. So this is my height. The second thing that then I need to find is my width, which is b minus a over n. And so b is 1, a is 0. So I end up with 1 over n. And this is my width. And so I'm going to find my limit as n approaches infinity of my sum from 1 to n of f of my height, so f of I over n, times my width, so 1 over n. Okay, and my function was x squared, so if I plug I over n into x squared, I get I squared over n squared. And I still have 1 over n. So if I multiply that out, I get I squared over n cubed. Okay, and n cubed, because n is just some number, is a constant, so I can pull that out front. So I'm going to end up with 1 over n cubed in front of my sum. So I'm actually just finding the sum of I squared. And the sum of I squared is n times n plus 1 divided by 4, I think. Is that right? No? I don't have all those sum things memorized. I squared, not even close. It's 6 and 2n plus 1. There's my sum formula. So this becomes that. I still have 1 over n cubed, and I still have my limit as n is approaching infinity. Alright, so if I multiply straight across, the top part stays the same, n plus 1 to n plus 1. The bottom becomes 6n cubed. Not like a lot, but like I think 6. It will end up probably being 0, yeah. Most of the time your limits as n approaches infinity become 0. I have to divide everything by n cubed. Do not just get 0. This is actually like stuff you'd use next year in calc. I don't know, but you'd use it in calc. Ryan said no. Alright, so if I divide everything by n cubed, I end up with all of those fractions divided by 6. So then if I simplify these fractions, what does 1 over n squared become? 0. Because we're still 0 times 0 times 0 divided by 6, which is 0. Sorry, Jenna. They're not always going to be 0. Sometimes you'll get real numbers. I'll try to do one where you get a real answer. So f of x equals 2x squared from the interval 0 to 1. So I know a is 0, b is 1. And the first thing I need to find is my height. So f of a plus b minus a I over n. So a is 0. B minus a is 1, so 1i over n. So my function of I over n is going to be my height, because 0 plus 1 is 1, and so I'm going to have to really write the 1. Then if I want to find my width, My width uses b minus a I over n. Well, we just said b minus a, 1 minus 0 is 1, so that just becomes I over n as well. Okay. Write that down, dummy. Well, write it down. I can go up. Alright, so if I plug in I over n into my function, then that'll give me f of I over n. So I actually have 2 times I over n squared. Okay, so that just becomes 2 times I squared over n squared. So 2I squared over n squared. So I'm going to find my sum of 2I squared over n squared times my width I over n. Alright, so if I multiply that out, I end up with 2I cubed over n cubed. And then I know that n over 3 is just a constant, and 2 is just a constant, so I'm going to pull those out front. So this will be 2 over n cubed. So all that's left is I'm taking the sum of I cubed. Okay, and your sum of any cubic function is n squared times n plus 1 squared divided by 4. Okay. Okay, and I still have 2 over n cubed out front. Okay, so if I square this, then I get n squared plus 2n plus 1. And I still have an n squared on top and 4 on the bottom. It's not 0, actually. I told you to pick one that wasn't 0. So then if I multiply through, I get n to the 4th plus 2n cubed plus n squared divided by 4. Okay, smart Alec. Alright, so if I put that n cubed back in, I get 2n to the 4th plus 4n cubed plus 2n squared divided by 4n cubed. Because then it's all one unit, and then I can start evaluating my limit. Because now I'm ready to evaluate my limit as n approaches infinity. And that gets rid of my sum. So then I don't have to take the sum anymore. Does that make sense, Kira? Kind of. Like if I push this all back into this equation, then I can get rid of my sum symbol. And then I can just take my limit from there. And then I don't have to worry about finding the sum anymore. Okay, and then we always say you want to get fractions. We're going to divide everything by our biggest exponent, which in this case is n to the 4th. So I end up with 2 plus 4 over n plus 2 over n squared divided by 4 over n. And then I evaluate my limit, and I know it is n approaches infinity. Anything with n in the denominator cancels. So I'm left with 2. I'll do 1d 0. No, you didn't. Okay, so you only have a few like that. 29 to 36, I think are like that. You'll do 5 through 11 odd, 13 to 20, and 29 through 36.